after we talk about a couple things. So the graphical behavior of functions, for a function to increase, this means as the input values increase, the output values increase. So the x values are getting bigger, the y values are getting bigger at the same time. This means the rate of change for this particular function is a positive constant because it's linear. So this one, the slope is always positive. And you can find it too if you just find the average rate of change. For decreasing, as input values increase, the output values decrease. For this one, the rate of change is a negative constant. And this is just based off of the image that's used. This won't be true all the time. So this is a negative constant because it's a linear function. It has a slope that is the same for every point on the graph. All right, for concave up, this is when a parabola is opening up. It doesn't always have to be a parabola, but in the picture below, it looks like a parabola. So when okay, so I misspoke before. This AROC, I'm using it as an abbreviation now for these definitions in order to save space. What I meant to say was never say it as increasing, decreasing, and increasing, decreasing rate, which is what we're going to talk about now. So I'm using AROC right now to save space. However, you do not want to write this on your AP exam, and I suggest that you don't write it in examples. So for definition's sake, we're going to use it, but avoid using it in examples, and I will too. So when the average rate of change over intervals is increasing, outputs are increasing at an increasing rate. Okay, so notice how I said that outputs are increasing at an increasing rate. I did not say the average rate of change is increasing at an increasing rate. So if I choose different points on this parabola here, let's start right here. At this particular point, the slope is negative, okay? But if we use average rate of change, let's choose 2 points. So the secant line here is negative, okay? If I keep going, I have another negative slope. Now, this is negative. I'm going to say this is more negative, but as I continue through the function, I can look at the slope of this secant line. It's less negative. And then as we come around the vertex here, if I choose another 2 points as I travel, this is going to become positive. And then I choose another secant line. This is positive as well, but this segment here is more positive than that first segment. So if we look at these average rate of change, the values that these pairs of points create as the input values increase, they are increasing. So this could be like, if I were to just make up a number, I have like -3 and then -1. And then on the flip side, this would be +1 and then +3. So these average rate of changes, they are increasing at an increasing rate, okay? They're getting bigger, okay? Let's not use those values though, because we don't know that that's what they actually are. Now on the other side, the same thing can be said for concave down. This is when it opens down. Okay, And this is when the average rate of change over intervals being, like, I chose these 2 points. For the secant line, that's the first interval, second interval, third interval, so on and so forth, is decreasing. The outputs are increasing at a decreasing rate. So if I were to choose, let's say this point, let's use blue for increasing. If I were to look at this average rate of change, it is positive. But now if I were to look at these two, the average rate of change here, it is less steep than the line before it. So they're both positive, but this one is more positive. This one is less positive. And then as we come around the vertex, if I were to choose another set of points, this one is negative. And then this segment is also negative, but this is less negative, and this is more negative. So if we go back to the vase example, if we look at this where the height is increasing at a decreasing rate, you can see that we do have concavity occurring. And this one is concave down, okay? And that's happening because the function is increasing. You see that it's getting bigger, but it slows down as we approach that line, which was the turning point for the length of the diameter in the vase. So after we pass that, we see another section where the concavity is now concave up. And that's because the height is increasing at an increasing rate. So when you talk about the outputs increasing at a decreasing rate, that creates concave down. And then when the outputs are increasing at an increasing rate, that means concave up. All right, so the definition for the rate of change is, let's see, this is referring to the slope of a function remember, f is increasing is not the same as the rate of change of f is increasing. This is a very important distinction throughout the course, but also if you plan on taking calculus, whether it be in high school or at the university level. So f is increasing. That means the function itself is simply increasing. It's getting bigger, okay? But when you say the rate of change of f is increasing, that means it is concave up. Because the rate of change itself is increasing, it's pushing the function to increase faster. So you can think of an exponential function, a parabola, depending on the rate and type of function it is. But all of those functions, they have concavity in common, okay? And we're going to take a look at that with these two examples. So this first one, we have graph of f. For 1, we're going to determine is it positive or negative. For 2, increasing or decreasing. And then 3, concave up or concave down. So for this first one, the definition of a positive function is when it's above the x-axis. The definition of a negative is when it's below. So f is positive because the outputs are all positive. And another way to say this is the graph lies above the x-axis. And then if we go down to 2, we want to ask, is it increasing or decreasing? Well, we can see that if we read it left to right, the outputs are getting smaller. So f is decreasing. Decreasing? Decreasing. because the outputs decrease as the inputs increase. AKA the graph is going down, or also known as. And the last observation is it concave up or concave down? If we look at this, we see that bowl shape. So that means this is concave up. Also based on the evidence from 2, it's lying above the x-axis and it's decreasing. So that means it will be the graph is concave up. Because in this course we use the rate of change for concavity, because the rate of change of f is increasing. Or another way to say it is the outputs are increasing Sorry, the outputs are not increasing, and I need to fix that on my key. The outputs are decreasing. Oh, wait, no, that is correct. Sorry. It's late. The outputs are increasing at an increasing rate. But the outputs, okay, I was right the first time. The outputs are decreasing at an increasing rate. Because if we look, the graph is going, the outputs are getting less and less, but they are getting less and less slower. So from this point to this point, same amount of time passes by. We are decreasing and it goes down by about 1. But if we look later, if we do use the same amount of time, we are still decreasing, but it's not decreasing as much, all right? So the outputs are decreasing at an increasing rate. And this can be a little confusing because if we just think about your secant lines, I have a secant line here. This looks like, I'm gonna throw ballpark number. This looks like the slope could be -5. But if I choose this one, it looks more like -1/2, okay? So the outputs are decreasing, but we can see that the rate at which they are decreasing, given similar interval sizes, is less as we travel through the graph from left to right. Okay, so that's how we know that it is concave up. All right, let's look at graph of G. So the first observation is it positive or negative? It is below, so F is negative because the outputs are all negative. AKA the graph lies below the x-axis. All right, the next one is it increasing or decreasing? F is increasing because the outputs increase as the inputs increase. Or another way is the graph is going up. And lastly, we want to talk about concavity. The graph is concave down because the rate of change of f is, if we look at the outputs, they are increasing. So the rate of change of f is increasing. But as we increase, if we think about choosing a pair of points over a similar interval of time, we have this one. That's like, I'm just gonna use 5 again. That looks like it could be positive 5. But if I choose a section later over a similar interval of time, this one looks like it could be plus 1/2. So the function is increasing, but it's increasing at a slower rate because the average rate of changes are getting less as the inputs increase. So it's increasing at a decreasing rate. And there is something I wanted to talk about here. My definition does not match with the concave up, okay? So I put when the average rate of change over intervals is increasing, outputs are increasing at an increasing rate. That is only specific to this side, okay? It's only specific to that side. Because in the blue, the average rate of change, the outputs are increasing at an increasing rate. On this side, I'll use the purple, the outputs are decreasing. Let me abbreviate. Are decreasing at an increasing rate. So the outputs are decreasing, but they are decreasing less. Therefore, we say that it's decreasing at an increasing rate. Okay. Now, for concave down, I said that outputs are increasing at a decreasing rate. That is only true for this side. For the other side, the outputs are decreasing at a decreasing rate. So I can see that the function is going down, but it's at a decreasing rate because the average rate of changes over similar intervals is decreasing more. So we say it's decreasing more. Also, it's concave down. So the takeaway is that concavity will always align with the rate at which the average rate of change is changing. If it's concave up, the average rate of change is increasing. If it's concave down, the average rate of change are changing at a decreasing rate. So just be careful with that. Okay, so some multiple choice. So number 3, the graph of h of t and its dashed midline for 2 full cycles is shown. 5 points f, g, j, k, p are labeled on the graph. No scale is indicated, no axes are presented. The t coordinate f is t sub 1 and the t coordinate of g is t sub 2. So this is actually pulled directly from the AP exam. It's on the AP exam for pre-calculus every single year, and it's always FRQ number 3, okay? So on the interval from t sub 1 to t sub 2, which of the following is true? Now, if we look at these coordinate points, the first observation is it positive or negative? Just look at the y values. We have 4, 0, -4, 0, 4. But we are specifically looking at from t sub 1 to t sub 2, which is going to be from, where's that from? T sub 1 should be f, t sub 2 should be g. So if we're looking at that, the y values are 4 and 0, therefore it's positive. So we can go ahead and X out C and D. The next observation is it increasing or decreasing? Well, if we look at it from F to G, the output values are going down, therefore it is decreasing. So the correct answer will be A. Whoop, B, sorry. Positive and decreasing. Part B says describe how the rate of change of h is changing on the interval from t sub 1 to t sub 2. So from t sub 1 to t sub 2, the graph of h is concave down because the rate of change of h is decreasing. So this question specifically wants you to connect concavity with how the rate of change is changing. So it's concave down because the rate of change of h is decreasing. The figure shows the graph of function k for the interval from 0 to 9, as well as 6 labeled points A through F. Use the graph of k for the following examples 4 through 7. All right, so example 4, on which of the following intervals is k negative and decreasing? So I'm only focused on what's happening below the x-axis, all right, because it says the outputs need to be negative. So if I check my choices, A to B is negative, B to C is not, so I can go ahead and X that out. D to E is negative, and so is E to F. But now I want to know, when is it decreasing? So A to B, that's actually increasing. The outputs are getting larger, so we'll cross that out. And then D to E, the outputs are getting smaller, so it will be C. Because if we look at D, from E to F, they are increasing, so it won't be D. Number 5, which of the following statements about the rate of change of k is true? Okay, so that means we want to look at the slope of particular sections. The rate of change of k is negative on the interval from A to B. Well, if we look at this, let me go ahead and erase this off. It says the rate of change is negative from A to B. If I'm thinking of the rate of change and I want it to be negative, that means the slope should be negative, okay? But from A to B, the slope is positive. It's going up. Therefore, this statement is not true. Part B, the rate of change of k is negative on the interval from B to C. Again, B to C, the function is increasing, so the slope is positive, and that does not align with this statement. So B is not correct either. The rate of change of k is positive on the interval from D to E. From D to E, it's decreasing, so that's not going to work. So the slope is negative because the function is decreasing, and that does not align. So part D says the rate of change of k is positive on the interval from E to F. This is true because if we look from E to F, the slope is positive because the outputs are increasing. Therefore, the correct answer is going to be D. And then number 6, which of the following statements about the rate of change of k is true? The rate of change of k is decreasing on the interval from A to B. So now we are looking at concavity. When you're talking about the rate of change increasing or decreasing, you have to switch your mindset and look at concavity, okay? So from A to B, if my rate of change is decreasing, that means it should be concave down, but it's concave up from A to B. So that means it should be increasing, but that's not what it's saying. So A is not correct. Part B says the rate of change of k is increasing on the interval from B to C. For the rate of change to be increasing, that means we want to see concave up, okay? But instead, from B to C, we see that it's concave down, so part B is not correct. Part C says the rate of change of k is increasing on the interval from D to E. So again, we want to see concave up because the rate of change is increasing, and it looks like we do see that. So from D to E, it is concave up, so we're going to go ahead and choose that. Part D says the rate of change of k is decreasing on the interval from E to F, which is not true because from D to F, it's concave up. Okay. I think we have one or two more questions. This is a pretty long video, but it's covering a huge topic. So on which of the following intervals is k increasing in the graph k concave down? Oh, this is still using the previous one. So now we have two observations happening simultaneously. So on which of the following intervals is k increasing? That means the outputs need to be going up and the graph is concave down. So we want to see it going concave down. So if we think about concavity, basically what I'm looking for is overall it's concave down, but I want to see specifically when it's increasing, it's going to be the part of the graph that grows either into a maximum or it could be a turning point in the graph. So let's take a look. All right, so there is a maximum here, and basically where the graph is concave down is going to be here. From B to like, it looks like D maybe? So I either have B to C or C to D, but it said when the function is increasing, which is going to be here because the outputs are getting larger. So the correct answer should be from B to C, so that's going to be B. All right, lastly, the figure shows the graph of a function f on the interval from -5 to 5. On what intervals is f decreasing? Okay, so this kind of wraps us back to what we did in the beginning. So f is decreasing on the interval from, I don't have to say from, on the interval -1 to 2. And that's going to be that middle segment there. So now, number 9 is asking on what intervals is f both negative and increasing. Okay, so negative means we want it to be below the x-axis, which is going to be this portion here. And then increasing means the output values are getting larger. Okay, so simultaneously that's going to be happening on the only part that is actually negative. So f is negative and increasing on the interval -5 to 3. Sorry, -5 to -3. All right, so that covers change in tandem and then graphical behaviors. I wanted to put all of that together because the practice work is one worksheet, and then the next topic will be rate of change, which will probably be another long video. So thanks for sticking this out. And if you have any questions, please let me know.